Hello, Mr. Collier here. We're going to continue our discussion of Chapter 2 by talking about matter. Matter, of course, is going to be the main topic as we study chemistry this year. And so we better start with a working definition. Matter is anything that has mass and takes up space. And by takes up space, we mean that it has volume. Mass is how much matter it has, and this is something that is constant everywhere for a particular object. For example, if you take it to the moon, it still is made of the same amount of matter. However, its weight will change because weight depends on gravity. So the weight of an object will change in different locations. A lot of people use these terms as though they are identical, but there is a slight difference here. Again, that difference is that mass does not depend on gravity, while weight does depend on gravity. So if gravity changes, then weight will change while mass will not. And so you're going to use different devices to measure them. Something that balances two things, one that is a known mass and one that is an unknown mass, that's going to let you truly look at mass. Something that just relies on springs that you push down on, that's going to depend on gravity, and it will need to be calibrated wherever that gravity is, like here on Earth. We're going to talk about some different types of properties that matter might have. This is probably a new term for a lot of people, an extensive property versus an intensive property. So extensive properties depend on the amount of the substance, for example, volume and mass. These are two properties that you can measure about any object, but both of them, volume, mass, and there's plenty of other examples, will depend on how much you have. More of a substance will take up more space and have more mass. To contrast this, an intensive property is independent of the amount that you have, like flammability or freezing point. It doesn't matter how much paper you have, it's flammable. It doesn't matter how much water you have, it will freeze at 0 degrees Celsius. Another way to classify the properties of matter is whether they're physical or chemical. Physical changes will not change the substance to identify them, like the density or the color, its melting point, and many others. Chemical changes have to do with how it reacts chemically, and to test these, you would have to alter the substance chemically. For example, whether it's flammable. If it is flammable, you're not going to have the same substance anymore because you just burnt it. The next thing I want to talk about is the states of matter and kinetic theory, which is how matter is put together. So there are three states of matter that we're concerned with: solids, liquids, and gases, and we're going to look at how their shape and their volume are defined. So the shape of a solid is going to be definite. Solids keep their shapes, and their volume is also definite. These have a set shape and volume. And the actual particles that make it up, the atoms and molecules, which we'll be talking about soon, they move very slowly in a sort of vibrational matter. They don't move relative to each other, and that's why it keeps its shape. These tend to have more organized structures. Some are crystals, some are not, but even the not ones are somewhat orderly. Liquids have indefinite shapes that can change, and they have definite volumes. So you can pour it from one container to another, and it will have the same volume, even though it will take the shape of its container. They exhibit translational motion, which means that the atoms and molecules can move past one another, which is how it changes its shape. These are somewhat organized. Like I said, they're more fluid. Gases have an indefinite shape and an indefinite volume, so these can expand or contract based on many different factors and take up different space as well as shape. They have translational motion, which means that the atoms and molecules can move past one another. They do it fairly quickly, and they kind of move randomly. There is a fourth state of matter, plasma, which we won't be studying too much in this course, and it acts a lot like a gas, but it's ionized, which means that its electrons have been stripped off, and you'll understand more what that means as we go deeper into this class. Now I want to talk about the kinetic theory of matter, the idea that all matter is made of tiny little particles. Gases are the particles that have the greatest amount of kinetic energy compared to the other two. Now, what makes a gas is how fast the particles are moving and the distance between them. These factors contribute to how much attraction there is between the particles. We'll talk a little bit later, not right now, about this idea of intermolecular forces and how attracted one atom or molecule is to another. And that comes down to a lot of different factors, but definitely playing into it is the speed of the particles and how far apart they are for whether that attraction can gain hold and give you a solid, a liquid, or a gas. Substances change phase when they overcome these attractions, or if they lose the ability to overcome these attractions. The overall kinetic energy, which we measure as temperature, will remain constant during those phase changes, which I'll show you on this next graph. So here we have something like water going from a solid to a liquid to a gas. And during these phase changes, we're going to see something interesting happen. While a phase is being changed, for example, solid melting into a liquid, the temperature is going to remain constant, which is shown on this graph by this flat line. That's because the heat energy is being used to melt the substance, and so the temperature remains the same. We exhibited this in our first lab when we boiled water and it went from a liquid to a gas, and during that time, the temperature remained constant. So there's special terms for all of these phase changes. Freezing is from a liquid to a solid, vaporization is from a liquid to a gas, and condensation is from a vapor to a liquid. This entire process, when you're going from a vapor down to a solid, is called a cooling curve, or when you're heating it up, it's called a heating curve. Here are those phase changes again for solid, liquid, and gas. But we've also now got a couple more to add in that I missed on that last slide, and that is sublimation is from a solid directly to a gas, sublimation, and from a gas back to a vapor is called deposition. These are less common, so you don't hear about them as often, but they can occur for different substances. Here we have a couple different diagrams looking at solids, liquids, and gases. You can see that typically solids are close together and orderly. Liquids, they can have different orientations and they're a little bit more spread out, and gases are the most spread out. Something unique about ice and water is that solid ice will float on liquid water. This is weird. Most substances aren't like that. The reason it occurs is that solid water has these gaps in it because of the crystal structure that decrease the density. They make it less dense. If we look at a different solid like mercury on the next slide, we'll see that its atoms are much closer together in the solid form. So if we put liquid mercury, it would not float. The solid would sink right to the bottom. The last thing I want to talk about is physical and chemical changes. Physical changes are things that do not change the identity of the substance, but they can change what the substance looks like. So for example, if you cut something, dye it a different color, or change its state from a solid to a liquid to a gas, these might look different, but they all keep the same substance. The identity of what that thing is still the same. To contrast this, a chemical change alters the identity of the substance. It rearranges the atoms, makes new atoms link up, and it's going to give you something different with different properties from the original substance. For example, burning or rusting. That will give you an entirely new thing that is not the thing you started with. There are some signs that a chemical change has occurred. There are 4 that I want you to remember. Gas being released is one, so you might have bubbles or an odor or something fizzing or smoking. A color change is a good one, although that can be confusing because sometimes physical changes can change the color, like dyeing something. Formation of a precipitate, which means some sort of insoluble solid that falls out of a solution. That'll make more sense as we go through the year. And the last is a temperature change. This can also be a physical change, like just heating something up. But if you mix two things and they sort of spontaneously change temperature without a heating or a cooling device around, that's a good sign that it might have been a chemical change. The very last thing I want to talk about is how during all of these changes and properties of matter, one law is always followed. Just like the law of conservation of energy that I mentioned before, the law of conservation of matter says that matter is not created or destroyed, it simply changes form. So you might get chemical reactions, but they're always going to keep the atoms present. And that is the end of section 2.